Constraints are an incredibly important part of Fusion 360. Although most of them are intuitive, there are certain unintuitive features which really should be developed on when working with constraints. So the first constraint is horizontal/vertical. To create a line, it would figure out where it's closest to, whether it's closest to the horizontal axis or to the vertical axis. In this case, although it's quite close to 45 degrees, it is slightly closer to the horizontal axis. Therefore, when I select horizontal vertical, you can see the line becomes horizontal. Another interesting thing to note about horizontal vertical is that it can ensure that two points are on the same axis. For instance, if I were to select this point and control select the origin, I can make these 2 points horizontal vertical, which allows us one axis of freedom. However, the line itself cannot move out of. If I want to, I can define this length as 25, and then as you can see, the position of the line itself is fixed, although the length is not. The coincident constraint is very simple. It is used to connect shapes, 2 points. It's it to the origin, which fixes its position, although you can still scale it around. The tangent constraint ensures that an arc is tangent to a line or a point. So since if I were to create a circle and have line as such, I could define the circle to be tangent to the line. And as you can see, the tangency applies to not just the points on the line, but to the projection of the line itself. And if I want to make sure of the line, I can simply make these 2 points horizontal vertical. And as you can see, the circle is a natural continuation of the line. Another simple constraint, if I have 2 lines, I can simply make their lengths equal, and now the lengths of these 2 lines are linked. So for instance, if I were to increase the length of this line, the length of the other line would be increased as well. Note that this is orientation of the line. Another important thing to note is that this works with any object that can be defined, such as circles. And as you can see, these 2 circles are now equal. The parallel constraint is used to ensure that 2 objects are parallel. For instance, I can have 2 lines as such, and if I want to make sure they're parallel, I can simply select the parallel constraint and make them parallel. This is very useful for geometry. I can see this line is free to move in all axes, however it cannot rotate. Fix is a very interesting constraint because it's ideally not very commonly used. What it does is that it fixes any geometry at that point. Now as you can see, this geometry cannot be moved. It can be scaled, however, but it cannot be moved in any way. So fix and fix is a very powerful tool. However, it's important not to misuse it. The most common use of fix and fix is when you're working with a spline, as those generally do not have very strongly defined geometry. So if you want to avoid changes being made to the spline as you connect it to other rigorously defined geometry, it might be a good idea to fix it. Then we have the midpoint constraint. So the midpoint constraint is slightly finicky, but it becomes very useful if you know how to use it. So if you create 2 lines, for instance, you need to make sure that they coincide at their midpoint. So you can click on the midpoint constraint, select the 2 lines, and as you can see, this is now positioned at the midpoint of the other. No matter what I do, they will always be at each other's midpoint, no matter what. The Concentric constraint is another very simple constraint. It is really used with circles. However, it basically ensures that the center point of both circles are at the same position. So for instance, right now they're already defined to be the same position, but if I were to create another circle over here and I wanted to make the two of them concentric, simply have to select this circle, and as you can see, they're both concentric. In most cases, this really achieves the same purpose as connecting the midpoints of both circles to. However, when you're working with arcs such as tangent arcs, that may not be as simple to do, so this is still a valuable constraint. Finally, we have the collinear constraint. The collinear constraint is basically an extension of the parallel constraint. For instance, if I were to make these two lines collinear, they would both exist on the same axis. So now this only has 1 degree of symmetry. Now this is not limited to the horizontal or the vertical axis. For instance, I could have the two lines like this and I can still make both of them collinear. And that's just a brief through of the constraints that you will be using regularly. Just remember, a lot of these constraints are intuitive and it's very easy to use them. You're not completely aware of how they work. The main important thing to remember with constraints is how the horizontal vertical constraint works, because it's not very clear that a horizontal vertical constraint can ensure that 2 points are on the same axis. However, aside from this behavior, the rest of the constraints are very intuitive and you shouldn't have any difficulty in using them.